In this video, we will look at color representation, or in other words, how are colors stored in a computer.
Namaste, my name is Ravi Reddy and welcome to my new video series entitled A Prequel to Programming. Things you should learn before you write your first line of code. Here I'll be trying to explain the fundamentals of computing and coding which are needed before you write your first line of code.
First, let's look at how colors are used in printing. They use the subtractive color model or the so-called CMY scheme, cyan, magenta, yellow. So here we have the cyan, magenta, yellow mixing schemes. And we can see here, this is cyan, this is yellow, and this is magenta. And if you mix cyan and yellow and magenta, we get black. If we get cyan and yellow, we get green. Cyan and magenta leads to blue. Mixing magenta and yellow gives you red. In actual printing, they use a CMYK. The K stands for black, because when you print, there's a lot of text and other matter which appears in pure black. So instead of mixing cyan and magenta and yellow to create black, they use a fourth channel of pure black. Let's look at how this CMY color mixing works using this small script file. So here we have cyan, magenta, yellow. Let's set all of them to 0. Cyan equal to 0, magenta equal to 0, yellow equal to 0, we get white. If we get 100% cyan, magenta, yellow, all three are sent to 100%, we get black. Cyan plus magenta, 100%, 100% leads to blue. Magenta plus yellow, 100%, 100% leads to red. Cyan 100% plus yellow 100% gives you green. Now you can also see different shades of gray. Suppose I set cyan to 40, magenta also to 40, and yellow also to 40. So you get a shade of gray. And if you increase these values, you get darker and darker grays. Let's try 70. You can see you get a darker shade of gray. This is the mixing of the CMY color palette or the subtractive color mixing scheme. Now let's look at the color information in computers where we use the additive color model or the RGB model. These red, green, blue form the three channels for the color. This is the RGB mixing model. We have here red and we have blue and we have got green. RGB mixing red and green gives you yellow. Mixing blue and red gives us magenta. Mixing blue and green gives us cyan. Mixing red and green and blue gives us white. So the color information is usually stored in 8-bit format for each color. So the red value is stored in 8 bits, which gives us 256 values of red, and the green in 8 bits, 256 values of green and 256 values of blue. This is for each of the picture cell in the image being shown on your computer. So that gives us a total of 2 to the power 24, or that is 16 million colors. Let's look at RGB color mixing. Here we see that red equals 0, green equals 0, blue equals 0 gives us black. This is known as the additive color scheme. I can set red to 255, that is a maximum value. We are using an 8-bit color per channel. So for each channel we have values from 0 to 255. So this is full red. This is green equals 255, which is full green. And this is blue. Blue equals 255, full blue. Now if I set red equals 255 and green equal to 55. If I mix them, I get yellow. If I mix green and blue, I get cyan. And if I mix red and blue, I get magenta. And if I set the red, green, blue values to equal values, let's say here I've set it to 100, and let's set blue also to 100. And you can see that you get a shade of gray. Now here, as we make these values smaller, the shade of gray gets darker. This is for RGB values 50, 50, 50. And of course, when you take all the values to 0, you get black. This is the RGB color scheme. This is the RGB color cube, which shows the two models, the CMY model and the RGB model, in a single picture. We have here blue, we have red here, we have green here. At the opposite vertices, we have here cyan, magenta, and yellow. And at this point, we have black. At this point, we have white. And all the points we join black to white are the various shades of gray. So how many shades of gray do we get? We get a shade of gray when red equals green equals blue. So in 8 bits, we can get 256 shades of gray. Now in HTML, we write these RGB values using the RGB function, or we can also use the shorthand hexadecimal notation. For example, 255 is FF in hexadecimal, 99 is 63 in hexadecimal, and 71 is 47 in hexadecimal. Similarly, here we can write 25500 as FF0000, and 127 stands for 7F, 7F, 7F. This is how we use colors in hexadecimal. There is another color model known as the hue, saturation, lightness cylinder, which is very popular among photographers. This is known as the HSL, HSP model. If you are interested more in photography and understanding this model, you can read on the net. Then there is another format called the raw image format for digital photography. Most of the modern digital cameras give you more than 8 bits per kernel channel. For example, if you have 12 bits per channel, that is 4096 shades per channel. So this leads to a total of 68.7 billion colors. And in some cameras, they use 14 bits per channel. So that is 16,384 shades per channel, leading to a total of 4.4 trillion colors. So having so many bits per channel allows us to do a lot of filtering and run a lot of image processing, so that the final image is still having a very good quality. Another small but important feature in most computers, we have seen that we store RGB values with 8 bits per channel, that is 24 bits, but they're actually stored in 32 bits. This is for historical reasons, that they like to align things in 4 bytes or 32 bits. So this leaves a 1 empty byte per pixel, which can be used for other purposes. So in another video, we will learn how to hide a text message inside an image so that there is no signs of any message being passed. So this is a method of passing secret messages known as steganography, which will be a topic of a later video. Thank you very much.
Please subscribe to my channel and hit the bell so that you will get notifications of my future videos. Thank you.